In this video, we'll further discuss a firm's profit maximization choices with different timing, in the short run and long run, respectively. First, we'll talk about short run. In the short run, the firm faces non-adjustable fixed inputs and their fixed costs. This feature matters for the firm's decision, and let's look at how it interacts with the firm's output choices to maximize profit. In the previous video, we derived the result that a profit-maximizing firm in a perfectly competitive market chooses an output level such that the marginal cost is equal to the price on the market. One implication of this result is that the marginal cost curve basically becomes the supply curve of the firm. Now let me explain why. Recall that the supply curve maps the market price to the output level that the firm is willing to produce. Let's pick an arbitrary price level here on this graph. Let's say at $8. Then the firm that maximizes profit under perfect competition would choose the optimal output level such that the marginal cost is equal to the price level. Then the firm that maximizes its profit under perfect competition would choose the optimal output level such that the marginal cost curve, which is this red one, is equal to the price level, which is $8. And this will correspond to this point E4 here with a quantity level of 285 units. Now let's pick a lower price, let's say $7. What's the firm's optimal output here? Well, it's where marginal cost is equal to price, which corresponds to point E3 here, or 215 units. You can keep trying this, and hopefully you will agree that the marginal cost curve is exactly the curve that tells us the firm's output level at different price points, which is exactly the definition of the supply curve. But there is some caveat. At the end of the previous video, we saw that the firm may not get a positive profit by following the prescribed optimal output level at price equal to marginal cost. So it is possible that the firm just chooses not to operate at all. In other words, instead of choosing the corresponding output level at each price point, it may be better for the firm to just stop operating altogether and choose output level equal to 0. It turns out that in the short run, the firm would opt out and stop producing if the price is below the average variable cost, or what we call shutdown. This is why on this graph, the supply curve plotted in solid red only overlaps with the marginal cost curve when the price level is above the average variable cost curve. When the price falls below that point, the quantity supplied is just 0, regardless of the price level, because the firm is better off choosing output equal to 0 now. Now let's think about this rationale through an example. Let's say entrepreneur Adam rented a shop with 1-year lease with a rent of $2,000 per month to sell cupcakes. And each cupcake costs $2 in labor and material to produce. And the price of each cupcake is $3. And Adam can only sell 100 cupcakes next month. So the question is, should Adam produce or shut down? To answer this question, we need to have a horse race between two alternatives. What would happen if Adam keeps producing, and what would happen if he shuts down production? The profit is always going to be revenue minus cost. And if Adam keeps producing, then the revenue is going to be $300 minus a variable cost of $200, and then minus the fixed cost in rent, which is $2,000. So without paying for the rent, the production would have made $100. But after paying for the rent, he's coming out with a loss of $1,900. Now let's think about the alternative. Let's say that in the short run, Adam is locked into the lease and therefore has to pay the rent regardless of the business. Then if he chooses to shut down, then the revenue will be $0. Well, of course, there's zero variable cost, so he saves on that. Then he still has to pay for the $2,000 in rent. So on the net, he would make a loss of $2,000 altogether. So clearly, he makes a loss either way, but producing will be better because the operation actually helps make up a little bit of that loss in fixed cost. Whereas shutting down would not help at all. Now let's think about two more alternatives from here. First, in this case, Adam has an average variable cost of $2, and the price is actually higher than that. But what if the price is below $2? What would happen? Does production still make sense? Can you pause the video and think about that for a minute? Well, if the price is below $2, then production will lead to more loss. When the price is $3, every unit produced will help contribute $1 after paying for the $2 variable cost. But if the price is below $2, then each unit produced will cause even more loss on top of the $2,000 loss in fixed cost. In other words, the revenue minus variable cost part would be negative, as opposed to the 100 or positive value here that helps contribute and mitigate the loss to some extent. So in that case, when the price is below the average variable cost, shutting down is a better option for Adam. Now let's think about yet another alternative. Let's say the price is still $3, but Adam was actually thinking about these two choices before signing the lease. Should he still operate? No, because by not producing, he pays no rent and no variable cost at all. That leads to a zero in the profit, which is way better than negative 1900 by production. So choosing shut down or Q equal to 0 is better. One observation from this example is that choosing Q equal to 0 or shut down can mean very different things in the short run and long run. In the short run, the firm can stop production, but still has to pay for the fixed costs. In the long run, the firm is not restricted to any fixed cost. So by not engaging in production at all, it can guarantee itself a profit of 0. Another observation from this example is that the decision of whether to follow the price equal to marginal cost rule depends on the timing of the choice. Being in the short run or long run may not necessarily alter the profit of the firm when it operates, but it changes alternative profit from shutting down, because the timing determines the fixed cost. From our previous example, we saw that when the firm has a fixed cost, the firm may not want to shut down. Now let's look at these observations at a slightly deeper level. From our previous example, we saw that when the firm has a fixed cost, the firm may not want to shut down even if the maximum profit from the price equal to marginal cost rule is negative. The firm is actually better off to keep operating if the price is above the average variable cost, because in this case, the revenue from production covers the variable cost and some more. So it would help cover some fixed cost and reduce the loss. Although it cannot fully make up for the entire fixed cost, so the profit is still negative at the end, but it does help make up some part of it. So operating is better than shutting down. On the other hand, if the price is below the average variable cost, then the firm is better off shutting down to avoid further incurring losses on top of the fixed cost. In the principles class, you might have seen this graph marked at 3 different regions. When the price level is above the average cost curve, the firm makes a positive profit. When the price level is somewhere between the average cost level and the average variable cost level, then the firm will make a negative profit or a loss, but the firm should still keep operating with the loss. When the price dips below the average variable cost, the firm is better off shutting down. And this point E1 here sometimes is being referred to as a short-run shutdown point. The short-run supply curve is therefore the marginal cost curve above this short-run shutdown point. And the supply curve just snaps back to zero for all prices below this point. These observations are actually quite general. Let's look at it from a slightly different perspective in terms of the timing of the firm's decision. We can think about the firm's decision as 2 subsequent decisions. In the long run, the operating decision is a blueprint. Everything is variable. If the firm decides to operate, it will invest in the fixed inputs and commits to the fixed costs. But once the firm is committed, it enters the short run. And the decision between operating and shutting down in the short run is the following. If it shuts down, then the firm still has to pay the committed fixed cost. Not operating would have no revenue, but also no variable cost. On the other hand, if the firm chooses to operate, then it will earn a revenue, but also incurs a variable cost and the fixed cost. Now, compare these 2 alternatives side by side. Shutting down will be better than operating if and only if shutting down incurs a higher profit than the operating profit. And that's exactly this inequality we have here. So if we look at this inequality, we realize that the negative f's will cancel out on both sides of the inequality. So the inequality is in fact equivalent to whether the revenue is less than the variable cost. And from here, we can divide both sides of the inequality by a positive amount of the quantity level, Q. Then the left-hand side becomes the price, and the right-hand side with variable cost divided by quantity level is equal to average variable cost. And this is exactly the rule we derived from the observations in the examples. In other words, shutting down leads to higher profit than operating if and only if the price is less than the average variable cost. Note here that the logic here is precisely the canceling out of the minus f in the first step. What it reveals is that the firm has to incur the fixed cost either way. Then fixed cost is becoming irrelevant to the choice because the firm committed to the fixed cost. So in some ways, it just becomes a sunk cost. Even though the firm may not have paid for it yet, it is still committed to and therefore has to pay for that regardless. So what matters is whether revenue is high enough to cover the variable cost. You will see through more applications that once we take a more formal approach to modeling, the timing of decision automatically brings out the notion of sunk cost in ways that are not immediately obvious to us. We can use the same framework to think about the case where the firm operates under negative profit. In that case, the operating profit of the firm is negative, but it is better than the profit the firm would have gotten if they shut down. We want to see if we can derive an equivalent condition for this case in terms of price. Just like the previous case, we can add f on both sides of both inequalities. So minus f and minus f here will cancel out. And on the right-hand side here, the second inequality will end up with f on the right-hand side. To rewrite this further in terms of price, we isolate revenue by adding variable cost on both sides of both inequalities again, which gives us revenue is greater than variable cost because we added variable cost here, and revenue less than fixed cost plus variable cost, which is here on the right-hand side. And from here, we can divide through by quantity, and that will give us average variable cost on the left, price in the middle, and because this is total cost, so total cost divided by quantity is just average cost. In other words, when the price falls between average cost and average variable cost, then the firm is better off operating than shutting down, although the profit level is negative. These calculations reveal exactly the same intuition we described above through those examples. Now we have established that in the short run, the firm supply curve is the marginal cost curve above the shutdown point, which is the lowest point on the average variable cost curve. We know from our lessons on demand and supply that the total market supply can be aggregated horizontally from individual supply curves. So in a market with many homogeneous firms, which means identical firms, the aggregate market supply curve can turn out to be very, very flat. And we can illustrate this idea in this graph. At the price of $6.47, each firm in this market has the same supply curve because they're identical firms. So their output level will be determined by the price equal to the marginal cost, which gives us this supply curve here above the short run shutdown point. So if there are two firms in the market, adding up their individual supply will give us a market supply over here with 3 firms, 4 firms, 5 firms, etc., etc. You can see the market supply is going to be flatter and flatter and flatter. With infinitely many firms, the market supply becomes almost perfectly flat. Because they all have the same shutdown point, the market supply just turns to 0 once the price falls below $5 here. What if the firms are not all identical or heterogeneous? Well, if the firms have different average variable costs, then the aggregate market supply curve will not be perfectly flat. And this is because different firms will now have different shutdown points. For instance, in this graph, firm 2 has a higher shutdown point at $6, whereas firm 1 has a lower shutdown point at $5. So when the market price is above $6, both firms will operate, and the market supply is the sum of both supply curves. But if the market price dips below $6 but still remains above $5, then only firm 1 operates, and therefore the market supply is just going to be the supply curve from firm 1. This way, if different firms have different shutdown points, even though you may have many firms in the market, the aggregate market supply curve will not be perfectly flat. Our textbook gives a wonderful example of heterogeneous firms with different average variable cost. In oil production, firms use different technologies. The traditional method uses oil wells that drill very deep into the ground or the seafloor to pump out oil constantly. The drilling process involves very high upfront cost in identifying oil fields and drilling, but very low variable cost in pumping the oil out. A newer method is fracking, which drives much of the surge in oil production in the US during the past decade or so. Fracking is a very different technology that pushes pressurized liquid with water, sand, and chemicals to fracture oil shale that are located much closer to the surface of the ground. it has a much lower fixed cost, but much higher variable cost to operate. As a result, the fracking firms have a much higher shutdown point compared to the firms using the traditional drilling method. As a result, the fracking industry frequently shuts down and reopens as the oil price fluctuates up and down since recession in 2008. On the other hand, the oil wells just kept pumping throughout most of these periods. We discussed the short-run profit maximization problem, which can be summed up as a two-step process. The first step is to find the optimal output level that maximizes the profit, assuming that the firm would operate. The optimal output level follows the rule of price equal to marginal cost under perfect competition. But finding this output level doesn't necessarily mean the firm has to produce. If the price level is below average variable cost, then the firm would choose to shut down. But as long as the price is above the average variable cost, then the firm may keep operating even though the profit may be negative. Now let's turn to the long-run problem from a similar perspective. In the long run, the profit is the same as the short run if the firm chooses to produce. But the profit would just be zero if the firm chooses to not produce, because in the long run, the firm doesn't have to commit to any fixed cost at all. Therefore, comparing these two alternatives, it is better off for the firm to choose shutting down if the profit from production is lower than the shutdown profit, which is zero. This inequality is equivalent to revenue is less than total cost. Divided by the output level Q, this is equivalent to price is less than average cost. In other words, in the long run, the firm chooses not to produce as long as the price is below average cost, or if the profit is negative. In the long run, because the firm doesn't have to incur any fixed cost, the firm will never operate with a negative profit. The long-run competition model is similar to the short-run problem. We can first figure out the optimal output level when the firm operates, and then we can decide if the firm will indeed operate by checking if the price level is higher than average cost. Comparing the short run to the long run, there are two major differences. First, the difference between the long-run average cost and the short-run average cost curves implies a different shutdown point. Second, the long-run marginal cost and the short-run marginal cost are also different, thus leading to different long-run and short-run supply curves. For instance, on this graph, at the price of $35 here, the short-run profit maximizing output level is at 50. Where the short-run marginal cost curve crosses the price level. But the long-run profit maximizing output level is at 110. This is where the long-run marginal cost curve crosses the price level. In this case, the short-run profit is illustrated by the area of this darker rectangle marked by A here. And the long-run profit is the size of this bigger triangle, or this entire area marked by B. In fact, because the firm plans for fixed cost optimally in the long run cost is always lower than the short run cost. As a result, the long run profit is generally higher than the short run profit. In the long run, it is frequently assumed that the firm in perfect competition has no profit. The argument is grounded in the no barrier to entry assumption. If any firm can make a positive profit, then more identical firms would enter the market. So more firms will then shift out the market supply outward. And then that will drive down the market price, and the cycle will repeat itself until the long run profit is driven down to zero, and firms will stop entering. One important lesson we saw from this video is that the timing of decisions plays a very important role in the trade-offs of the firm's decisions. Timing is a very important modeling element in economics. It is important to define the timing of the model clearly. This process usually helps us clarify the assumptions we make and break down the complex environment for further analysis.